안녕하세요 여러분, 혜리입니다. So in this video we're going to start learning probability distribution. So first we're going to start with some basic terminologies. So if So we first need to know the term random variable. So if x1, x2 to xn are all the possible values of x, and if p1 to pn are the probabilities respectively, then we say x is a random variable, and then we can construct a probability table. So which looks like this. So we put the possible values of x on the top, and we put the probability in the bottom. So when x equals to x1, x equals to x2, and all the way to x equals to xn, then we said that the probability p1 is corresponding to x1, right? p2 corresponding to x2, and all the way to pn, okay? And the relationship between each x values here, let's say I, so I can be any natural number, xi, and pi, so this probability, so it's called the probability distribution. Of x, okay? In other words, we can write it as probability of x equals to xi as pi, okay? So this is the definition of random variable, and please be aware that we are looking for the discrete random variable. So discrete, as I said before, means we can distinguish the numbers. So x1, x2, all the way to xn. Okay, so there's a clear difference between x1 to x2, right? So x1, x2, like that. So we can distinguish them. There are some properties that you have to know for every probability distribution. So everyone should be able to understand this from probability, right? A probability value of a probability should always be between 0 and 1, right? And includes it can be the entire probability or just not happening at all, okay? And we're going to use the sigma notation. So if you are still not familiar with sigma notation, please study series again, because we're going to this symbol is going to be used a lot. So that equals to 1, and what does this mean? Sum of the probabilities equals to 1. So the sum of the probabilities equals to 1, and that clearly makes sense, right? That's what we learned from probability. And lastly, so if you have something like x equals to xi or x equals to xj, then we can just consider it like this. And this is because each outcome of x is considered independent. So remember that if two events are independent, then we can just add them separately, right? If we're looking for the union. And so this is assuming that every discrete random variable or So in distributions, we assume that the random variables are, the outcome of random variables are independent. There is one exclusion called the hypergeometric distribution, but that is not in the syllabus for the core, and also it's not the syllabus for the HL statistics option. So you don't have to worry about independent case, okay? All right, so that's the basic definitions and properties. And let's go to more technical thing. So let's look for the expectation value. So expectation is basically mean, okay? It's the same as mean, but just the fact that we don't have frequency, right? So it's not like the frequency table. Instead of frequency, we have the probabilities of an event happening. So we expect certain amount of event happening. That's why we call it as expectation. So let's just please draw the probability table. And for discrete random variable, just constructing a probability table is going to be very useful. So the expectation EX, which is mu, it's the same as how we compute the mean for frequency table. So frequency-based data. What did we do? So for every x values, we multiply the frequencies, right? And then add them up, right? It's exactly the same. So what we do is that we multiply x1 p1 plus x2 p2 plus all the way until xn pn. And also in the frequency-based data, we divided this by the sum of the frequency, right? For this one, we also divided by the sum of the probability, but as we all know already, the sum of the probability equals to 1. That's why we don't write any denominator. So using the sigma notation, we can write this as xi times pi, or in your most of your textbook, they will write it like this, right? So same thing, that means the probability of x being xi, and that's what it is, right? So that's the expectation. The thing is the variance, and I don't think we will have enough space, so I'll write on the other page. So variance of x, let's recall the definition of variance again. So variance is the average distance of each data from the mean squared. So I know it's very hard to understand this, but for example, if you have a mean here, and if you have like datas here, for example, so x1, x2, x3, and x4, x5, and x6, then we can see how far each data is from the mean, right? So we have these distances, right? But note that if the data is bigger than the mean, then the distance will be positive value. But if it's below the mean, then the distance, we will get negative value because we have to subtract from mean to mean by x1 and subtract mean by x2 and so on. So for that problem, so we could use the modulus sign so to indicate the difference, but modulus is very difficult because you will have to evaluate all the data, right? So you have to evaluate all the data, so whether it's positive or negative. And so for the positive one, we just leave it, and for the negative one, we put minus. But it's going to be very time consuming if you have a lot of data. So what we do is that instead of just putting a modulus, we square it. We square it and then we take root later. So if we square it, then no matter it's the thing is negative or positive, it will be positive if you square any number, right? Unless it's complex number, but we don't use complex number in the data. So what we do basically here is that for every data xi, we look for the distance from the mean and we square it, okay? And then we basically look for its average. So like what we did for expectation. So remember, expectation of x, we multiply its corresponding probability and then sum it, right? It's the same. We're looking for the average of each data. I mean, how far each data is from the mean squared. So we're basically looking for this thing, okay? And that's the definition of variance. So variance is the average of each data from the mean squared, okay? That's why we have this, and then we multiply by probability and add it up, like what we did for mean, okay? So, but this is the definition, but this is not gonna be efficient to use and apply in questions. So we're going to rearrange this a bit. So first we're going to expand the bracket out. And here we need to have some good understanding of sigma using sigma notation. So again, if you're not really familiar with sigma notation, please study series again, okay? So this is what we have, and so sigma can be just distributed like this. All right, so that one is, so what does this mean? It means the average of xi squared, right? So that means it's ex squared, because expectation is again average, okay? So ex squared. And for this one, using the sigma notation, this 2 mu, oh, we call this mu, okay, by the way. So mu as in expectation, okay? So 2 mu, they're constant. So we can take it out. And then we sum xi times pi. And you guys should know what this is, right? We have just seen it. But so I'm moving on. So mu squared is also constant. And we are adding all probability. So we have ex squared, and as I said, what does this mean? This is mu, right? Because that means that's the expectation value. So we have minus 2 mu squared, and that one is the sum of probability, so that's 1, right? That means 1 times mu squared is just mu squared, so we have this, okay? So that means if we have to find the variance of data, then we just, so what we can do is that if you have something like this, how do we compute this? We square them and we just multiply by its corresponding probability and add them up. That's it. So this is simply xi squared times pi, right? So I equals to 1 to n. So that means x1 squared times p1 plus x2 squared plus times p2, all the way until xn squared times pn. So simple to calculate, right? Last thing is the standard deviation. We usually use this sigma. So everyone knows how to compute standard deviation. It's just the square root of variance. And here we omit the negative because sigma is, what's the definition of sigma? It's the average distance of each data from the mean. So distance cannot be negative. That's why we do not consider negative sign, okay? So let's try an example. So let's say we toss 2 coins and let the number of heads be the random variable x. So A, construct a probability table. B, find the mean. And C, find the standard deviation. Okay, so let's quickly do A first. So A, constructing probability table will not be hard because, so what are the possible values of X? It can be 0, 1, and 2, right? No heads, 1 head, 2 heads. So X value can be 0, 1, and 2. And probability of having such value, so 0 head, that means 2 tails, which is 1/4, 1/4. And 1 head, that means 2C1, 1/2 times 1/4, which is 2/4, right? Head, tail, or tail head, okay? And 2 heads, obviously it's 1/4. So we can see that it sums up to 1, okay? So that means we didn't miss anything. Alright, so that's A. So after this, it's gonna be much easier to calculate mean. So the mean, we can directly use the formula, but also we can just find it based on this probability table. So this times that, which is 0, and this times that, which is half, plus half, so it should be 1. So that's the expectation value, okay? And C, we have to find the standard deviation. So that means we have to find the variance first, right? So variance is expectation of x squared minus mean squared, right? So we have to find EX squared, which means that we square these values. So 0 squared is still 0, so we don't really have to care about this. 1 squared is still 1, so that's half. And 2 squared is 4, so that's 4 times quarter is 1, so it's 3/2. So the variance will be 3/2 minus 1, right, which is half. So standard deviation will be √1/2. Okay, so not that difficult, right? Now for both SL and HO students, we are going to learn distribution. So as I said, the definition of probability distribution is the relationship between x1 and p1. I mean xi and pi. So there are a lot of different things that we can put it as random variable, and among those certain things, they have a similar pattern. And for those, we can group it as some kind of distribution and then apply the properties of that distribution. So what we're going to learn is the binomial distribution. So binomial distribution, there are 3 conditions that you have to satisfy first in order to use it. So total number of trial must be given. That means you should know how many times you're trying the event, okay? And the outcome must be either success or failure. So that means only 2 events, outcomes. And this, in other words, we can also say that probability of success is given. So for the previous example that we have done just now, so we said that the number of heads be the random variable, right? So we can see that we can let the success be of obtaining head and failure as obtaining tail. And there are only 2 outcomes, right? So this is in fact an example of binomial distribution, because so those 2 coins, we have the total number of trials, and then we have the success or failure, and one more last condition which this example also satisfies. So each trial must be independent. And clearly it is for this example, because tossing a coin should be independent to each other, right? So yeah, that's an example of binomial distribution. And so these are the conditions that you must check in order to use binomial distribution. But to be honest, for SL students, the only discrete distribution, probability distribution that you learn is binomial. So whenever you see like a discrete random variable, then you can probably just use binomial. But be careful, because sometimes so not like this example, but in other example asking you to construct a probability table and then finding mean and SE, it may not be the binomial distribution. So just read the questions carefully, okay? So binomial distribution, as I said, it's a distribution, so it has a relationship between the random variable x, the values of random variable, and the probability of it. And we call that relationship as probability density function, PDF. So the PDF basically tells you to find this. So probability of the random variable having a certain value of x. And we define this as ncx times p to x and 1 minus p to n minus x. And that is the binomial coefficient that you guys should all know by now, okay? The expectation is defined as np. The derivation is not that hard if you know well about binomial distribution, but since you have to do a lot with this binomial coefficient, so I'll not do it, and it's not in the syllabus either. But yeah, so it's really not hard to derive it if you have a good understanding in binomial theorem, okay? So variance of x is defined as npq. Variance is slightly harder than expectation, but still, again, if you have good understanding in binomial theorem, deriving this should not be that hard, okay? So we have these three properties. So that means if you can check that a random variable satisfies these three conditions, then you don't really have to do this. So you don't really have to like construct a probability table and then find the mean based on this, find the variance based on this, okay? You don't have to do that. So let's try an example. Let's say a bag contains 7 white balls and 3 black balls. And a ball is drawn or taken out from the bag randomly with replacement. If 5 balls have been taken out, so first A, find the probability of having at least 2 white balls, and B, find the mean and the variance. So the solution. So okay, so this is an example of binomial distribution. So that means obviously we have to use binomial distribution, but let's try to see whether the question actually satisfies all these conditions, okay? So a bag contains 7 white balls and 3 black balls, right? And a ball is taken out from the bag randomly with replacement. If it's without replacement, then does it satisfy the last condition? No, it doesn't. It has, so in order for each event, each trial, as an independent, then we must make a replacement. Okay, that's why this, so without this condition, then it's not a binomial distribution. Okay, so you will have some questions in your test or your final exam where you do not put any replacement. That means it's not a binomial distribution. Okay, and it is very possible. It's certainly possible for both SO and HO to have such questions. And again, so if 5 balls have been taken out, that means total number of trial is given, right? 5. And the outcome is either success or failure because it's either taking white or taking black. Then some may ask, then if we have like 7 white balls, 3 black balls, and 2 red balls, let's say, and for question A, is this not binomial distribution? Well, that still is a binomial distribution. Why? Because we can define success as white balls, and we can define the failure as black balls or red balls. So it really depends on how you can define the variable. Okay? So for every distribution question, you first need to define the variable, the random variable. Second, you have to define the distribution. That's 1 mark. If you don't do that, you'll get 1 mark deducted. So this question has not defined any random variable or distribution. That means we have to define it by ourselves. So let's say x as number of white balls. Then x follows binomial distribution. So for this binomial distribution, we have to know that it can be written like this. So x, the random variable x follows binomial distribution with n and p, and these parameters, n is the total number of trials, and this p here is the probability of success. Okay, so that means for this example, it's 5 and 7, 10, right? Because we're looking for the number of white balls, right? So that's obviously 7 over 10, right? So A, find the probability of having at least 2 white balls, right? So note that PDF of binomial distribution is like this. So it's just looking for 1 value, right? But what if we have to find the case where we have to find at least 2 white balls? Remember this? So if it's union, then we just add them separately. So that means at least 2 white balls, then px equals to 2, plus px equals to 3, plus px equals to 4, and plus px equals to 5. And you can add them up. Also, what you can do is that you can use your calculator. So for distribution, I'll tell you how we can use the calculator. So first, go to menu, you see statistics, and you see distribution. And you'll see a lot of distributions you can see. So we can just go down and you can see there are binomial PDF, binomial CDF. So PDF gives us 1 single value, okay? CDF means cumulative. So this is definitely cumulative, right? So we go for CDF, and it just asks you for number of trial, which are the parameters, right? So number of trial here is 5, and the probability of success is 7 over 10, and lower bound is 2, right? So we are looking for 2 to 5, so 2 and 5, and you will have the value. Okay, so you don't really have to calculate it by yourself. Or what you can do is that if you don't want to use cumulative function, for example, then you can use sigma notation from I equals to 2 to 5, NC, so we have 5, so n is 5, so NC x, where x is I here, right? P, which is 7 over 10 to I, and 1 minus p, which is 3 over 10 to 5 minus I. And you can also use sigma notation to do this. So let's say I from 2 to 5. So n 5ci times so they will give you the same answer. Okay, so well, clearly using the function of the calculator is much easier, so you can just use the calculator. Okay, so that's an example of binomial distribution. And we have to do B. So we have to find the mean and the variance. So the mean expectation of binomial distribution is NP, right? And N here is 5, and probability of success is 5/10, so 7/10, so we have 7/2. The variance is NPQ, where N is 5, P is 7/10, Q is 3/10, so that's 100 actually, so we can just directly cancel, so that's 21/20. Okay, so that's it for binomial distribution. And now for SEO students, you can stop the video. You're done with discrete random variable, so we are going to move on to HO syllabus. So HO students, please keep watching it. So we're going to do Poisson distribution. So Poisson distribution is another kind of discrete random variable distribution. So for this distribution, there are other conditions we have to check. So for Poisson distribution, the average rate of success must be given, and each success must be independent. And the PDF of Poisson distribution, so PDF, so we have e to minus lambda, lambda to x over x factorial, and this lambda here, so if x follows Poisson distribution, the parameter lambda is the average rate of success. So yeah, we can find probability like this, and the expectation is lambda, and variance of x is lambda. And in order to prove this, you need I don't think you learned this in calculus options, so you need one of the series, infinite series. So yeah, you need this to prove these two. Okay, so proof is definitely not in the syllabus, so we're not going to talk about it. One thing about this, so average rate of success must be given. As I said, this lambda, one thing about this lambda is that you have to be very careful with the time. Okay, the interval of time. And I'll tell you what I mean by interval of time. So for example, a call center receives an average of 0.6 complaint calls per hour. So find the probability of having at least one cause in the first hour. And second, the probability that it receives exactly 3 calls in 4 hours. Alright, so let's see. For question A, so okay, before we directly solve the question, as you can see, the random variable or distribution is not defined in the question, so we have to define it by ourselves. So x, let's say x, as the number of calls, and be careful with this, you should not finish it here. You have to put the time interval as well. So number of calls in an hour. Okay, and x follows Poisson distribution of 0.6. And A, find the probability of having at least one call. So that means so px equals to 1, px equals to 2, and then it just goes on and on, right? Is there any limit? Theoretically, there isn't. So that means we have to add up to infinity, but that means we can't really compute it, right? So what we can do is that we use the idea of complement. So that we can just make it as 1 minus the case where we don't receive any call, right? Because 1 here is the sum of the entire probability, right? So px equals to 0, px equals to 1, and all the way to the end will be 1. And we just simply subtract px equals to 0. That means 1 minus e to minus 0.6 using the probability density function, okay? Question B, so we have to find the probability of receiving exactly 3 calls in 4 hours, right? But remember, the random variable that we defined is in an hour. So what we can do is that we can use the other variable. So number of calls in 4 hours, then y will follow Poisson distribution of 2.4, because each hour we receive 0.6 average, right? That means in 4 hours we will have 0.6 times 4 complaint calls in an average. So that's the new distribution that we have, and we want to find the probability of receiving exactly 3 calls. So that's py equals to 3, right? That means e to minus 2.4, 2.4 to 3 over 3 factorial. And that's it. So put it in your calculator and you're done. And again, you can also use the calculator directly without using this PGF. So you see that if you just scroll it down, you'll have Poisson distribution here, right? So Poisson PDF is again just one value. CDF is all value. So for example, lambda equals to, so for this one, let's say, so if we want to find the call until like at most 7, let's say, then we just add from 0 to 7 at most, and you can find the value, okay? So not that difficult, should be, right? The important thing to remind you is that so I've been asking for mean and variance only for so far, and of course you'll also have some questions asking you to find the median and mode, and don't worry about that too much. So just apply the definition of median and mode. Median is right in the middle, right? That means for the value of the median, we will have the probability of 0.5, right? So just use that. So it's simple algebra. And also mode, that means having the most frequent data, right? That means the highest probability. So find for the maximum. One thing, finding for the maximum. So some students sketch this. So try to sketch this to find the maximum point. One thing to tell you is that you may not be able to sketch it sometimes, especially when you use the sum, because sum is for discrete data and graphing is continuous data. So sometimes you will have nothing on the screen with certain inputs. So what you have to do is that you should evaluate the value by value. Okay? So that's it for discrete random variable, and see you guys later in the continuous random variable. Bye.